if I have this graph and this is the curve, okay, for example, y equals to fx, okay, and I want this area under the curve. Let's say this is from A to B. I want this area, okay. I will integrate from A to B fx dx to find this area. Understand what I'm talking about? Okay, class? Can? Can, huh? Now, even if I have a line, okay, for example, this one is y equals to x plus 3. Okay, I can also integrate, right, the line from A to B, right, to get the area. Everybody clear? Everybody clear? Okay. Now, the problem now is not this side. I'm going to tell you all the things that are in this particular part first before I start the section. What if I have a curve? Let's say like that. This is above, right? This is above, right? What about here? It's below. Once it's below, the area will become negative. Understand? In order to make it positive, you see this area, supposing this area is, let's say, negative 4. So in order to find this area, I must put negative 4, right? Because it must be a positive number now. Correct? So I must minus this area in order to plus it. Understand? I will show you later with the examples. Will that be okay? Alright, so area under the x-axis but bounded by the curve is a negative value. So in order to make it a positive value, I must add a negative sign in front. Everybody clear? And one more thing. Sometimes I have a curve maybe like that, and I want this area. This will be bounded by the y-axis and the curve. Then you got to make sure that you got to write x in terms of y. Then you can integrate. Okay? Then you must dy, you cannot dx anymore. So these are the few things that I need to caution you first before I start the whole chapter. Are you all clear? Okay, I will go through again, don't worry. Alright? I will tell you exactly where it is. Okay, now let's take a look at the questions, at the lesson now. Okay. Let us take a look at this. Okay? Area of a region above the x-axis. That means if I have y equals to fx, this one must be fx. That means must be in terms of x. Okay? And a to b, the area is given by integration from a to b fx dx. Understand? I will show you the working later. Okay? No need to copy, it's in the textbook. It's found on page 122. Everybody clear? Okay, now I'm going now to example 5. Now why am I showing this instead of doing it at the board? Because it's faster. The manipulation, I've already done it. Manipulation, I think you know how to substitute it. It's just that you need time to work through the answer. Okay, now let's look through the question. Can all look at example 5. The diagram shows part of the curve y equals to 5 over x squared. Find the area of region A. Now I want you to look at the board. Region A is this part, right? From 2 to what? 3. I must integrate this, right? Then I can get this reason, this area, right? From 2 to 3, I integrate this guy. Am I right to say that? So area of A, all of you look, will be, I can take out 5, right? Because it's a constant. Then negative 2, then I have this, right? 3, 2, right? Then I plug in, I substitute and I evaluate. I will get a 5 over 6 unit squared. Is that clear? Is that okay? Okay, right. I just plug in the values. Everybody okay? Alright, Now, then what is the next part? Part 2. Find the value of K such that the area of region B is equal to the area of region A. Okay, I want you all to look at the picture here. We already found that this guy is 5 over 6, right? The area. So when I integrate from 3 to k, I must also get 5 over 6, right? Because the area is the same. Agree, class? So 3 to k. So I plug in. I will form an equation. Then I solve. I will get your k as equals to 6. Are we okay? Are we okay? So, can you see that in this particular example, the region that we want to find, here, is all bounded by the x-axis and above the x-axis and this curve. Understand? So, it's always a positive value. Is that clear to everyone here? Everybody okay so far? Everybody okay so far? Okay, huh? Alright, good. That will be your example 5. Next, I'm going on to example 6. Okay, example 6 shows you this picture. Can all of you look at the question? The graph of y equals to square root 1 minus x squared is shown. The region bounded by the curve and the x-axis is a semicircle. Explain what, when you integrate 0 to 1, this one represents. Now, I want everyone to look here. When this is 0, when this is 0, do you agree this is 1? Right. And they tell you this guy is a semicircle. So, if this is 1, this must be 1 unit also, right? Because it's the radius one. Can you see? That is how I get the 1, 1 and the negative 1. Are you clear? Yes or no here? Yes, huh? Okay. What does the first part represents? Now, this part, when I integrate from 0 to 1, is the one that I've shaded. It represents the area of the quadrant of the circle of radius 1 unit. That means I'm finding out this area, right? Just 1/4 of the circle. Agree, class? 1/4 of the circle is called what? Quadrant. Okay? Now, next part. What did the question say? The question say, hence or otherwise, find the value of this. Now, actually it's very easy. I don't even need to integrate. Okay? I don't even need to. They say hence or otherwise, right? It's either from the previous part or you integrate also can, right? Okay? Now, do you agree this one is a circle, so it's pi r squared over 4, right, for a quadrant? What's the radius? 1. 1 unit. So, pi 1 squared over 4. So this is a pi over 4, right? Straight away. Now, why did the question say hence or otherwise? Once you see hence or otherwise, you can also integrate. But if they say hence, you must use the problem. Because you must use the previous part. So, can you see that when I integrate this, I don't even need to integrate. I just put 1/4 pi r squared, I start in 1, I will get pi over 4. Can you see what I'm talking about here? Yes or no? Now, then someone will say, Joe, what if I want to integrate, then how? Okay, then integrate like I see how, okay? 0, 1, right? What is this? 1 minus x squared power half dx, right? Okay, I integrate, what will this be? 1 minus x squared. What do I have here? What do I have here? Power? Power 1. Correct now? Power 1. But actually, this one is not in your syllabus yet. Inside, if there's a square, you integrate become 2x, cannot. You only can divide by a constant. That means inside must be here. You get what I'm talking about? We always integrate like that, okay? All of you. Okay? Then when I integrate this, right, I will get 3x plus 1 power 3 over 3, right? Then divide by 3. It's always only divided by a constant. You don't divide by x or anything. So this one, in fact, you cannot use otherwise. You can only use hence. Because it's pi r squared over 4. Do you get what I'm talking about here? Yes or no? Yes, huh? Okay, good. So, let's look at the next part. Are we okay so far? Are we okay so far? Can or cannot? Can or cannot? Okay, huh? Alright. Now, what I say, right? Okay, never mind. I show you something. Okay, on indefinite integral. Just a minute, I show you something. Yeah. Can you look at page 99? You look at this part here. Can you see that you only have this case where ax plus b is linear inside? You only divide by a and then n plus 1. That's all. There's no ax or whatsoever. Okay. Those other things you'll do it at a higher level. Everybody clear? Okay. All right. Next, I'm going to move on. Can we now look at example 7? Can all of you look at example 7? I have the diagram here. Okay. Now, let me read the example 7 for you. We have all together until example 12, but it's very easy to apply the concept. You understand what I'm talking about? So you must listen to me. Okay, let's look at example 7. The diagram shows the line x equals to k and part of the curve y equals to e to x. Find in terms of k the area of the shaded region bounded by the curve y equals to e to x, the line x equals to k, the x-axis and the y-axis. Okay, all of you look up. I'm not going to go through this. Can you see they want this shaded region? Correct. Okay, all of you look up. Can you see this shaded region is integration from 0 to k of this function? Agree or not? Because it's like that, from here to here, correct? Okay? Okay. But they want it in terms of k, right? Because we don't know k. So we are going to integrate this. Now, all look up. If I integrate this, I keep this, right? Then 1 over differentiation, 1 over 2. Can you see? Then k 0, correct? Am I right? Then I plug in k, then I plug in 0, so on. So I'll have this unit square. Okay? You ask me, what if I leave it like that? Is it okay? Yes, it's okay. Everybody clear? Yes or no? Okay. Now, then the second part. All of you look at the second part. Given that the area of the shaded region is 10 square units, find the value of k, correct the 3 cylindrical figures. Now, of course, this is very easy. You just have to equate this to 10, right? Agree? You equate this one to 10, then after that, you solve it, right? By taking log. Can you see it now? So it's not that difficult. Okay? Can or cannot? Can or cannot? Can, Okay. Next one. Can we look at example 8? Am I too fast? Do you know what I'm saying? Do you all know what I'm saying? Do you know what I'm saying here? Yes, Okay, now. Then I want to ask one question, All of you look at the board. If I have a curve like this, let's say this is -3, this is 4. I want this area. I should integrate from what? -3 to 4. With the fx function dx. Understand why? Because it's all above. You don't have to bother. Everybody clear with what I'm saying? Can or cannot? Okay, so you just take the front and then the back. That's all. Okay? Alright, now next, let's take a look at example 8. Example 8 shows you a trig function, trigo function. Okay, this is the trigo function. Okay, I want everybody to look at about here. Okay. What did the question say? The diagram shows part of the curve y equals to 2 plus 4 cosine 2x. Okay? Meeting the x-axis at the points P and Q. Show that the x-coordinate of P is pi over 3 and find the x-coordinate of Q. Now, do you agree that it cuts the x-axis at P and Q, that means y is 0? Do you agree y is 0? Yes, okay. So, I will equate. All of you look up. I equate 0, this is 0, so I have basic angle pi over 3, right? Correct. So I will have 2x equals to, because it's negative. Negative means here and here, right? I'll have pi minus pi over 3 and pi plus pi over 3, correct? Everybody okay? Okay, then I have two values, pi over 3 and 2 pi over 3. Now, of course, pi over 3 is nearer to the y-axis, alright? So, the x-coordinate of p will be pi over 3, and the x-coordinate of q will be 2 pi over 3. Are we okay? Are we okay so far? This is some trivial parts that we need to know. Okay? Alright, now then we need to look at the next part. What did they say? Find in terms of pi the area of the shaded region. Okay, I want all of you to look here. Shaded region means I must integrate this curve, right? From where to where? From 0 to what? Pi over 3, right? Can see? Can see what I'm talking about? Okay, can? Can, huh? So I'm going to integrate this from 0 to pi over 3. Okay, I do the integration, I sub in, then I will get this answer. How many units squared? Are we okay so far? Are we okay so far? Can or cannot? Can or cannot? Can, huh? Okay, good. That is example 8. Okay. Next, we are going on to the next part, whereby we have an area under the curve. Now, all of you look at this one now. Ryan, can you wake up? Zhen Xian. Hey, class, I know you are tired now. As I say, I'm also tired. Understand? Okay, look at the board now. Now, can you see this area is below the x-axis now? Everybody clear with what I'm talking about? It's below the x-axis. Okay, so what did the textbook say, or what is the concept behind here? Okay, all of you look up. If a curve y equals to fx is below the x-axis over the interval a to b here, okay, then the area A bounded by the curve, the x-axis and the y, and the lines A and the line x equals to b is given by A equals to negative from A to B. Okay, now why is that so? Just now I told you right in the beginning. Okay, now class, all of you look up. I'm going to show you this, all of you look up. Let's say like that, something like that, okay? This is y equals to fx. Everybody okay? Now let's say this is A and this is B. I want to find this area. Now all of you look up. The area will be, I integrate from A to B fx dx, right? If it's above the axis, it's also like that, right? But if it's below, this is a negative value. So in order to make it a positive, that means this whole thing is a negative value. Okay? Repeat, I use another color. That means this whole thing is a negative value. Area cannot be negative, right? So, in order to make it positive, I'll put a negative in front. Understand? So, if it is below the x-axis, what we must do is negative integration of this to make it positive. Everybody clear with what I am saying? Yes or no? Okay? Alright, now, then, let's take a look at this part here. Okay? Can you see here? A is integration of A to B fx dx. Now this is negative. By putting a negative in front, I will make the whole thing what? Positive. That's why it's a positive answer. Area cannot be negative. How can I have a negative area? You understand what I'm talking about? Can or cannot? Can, huh? Okay. Now, then we move on to the next portion. Are we clear? Are we clear? This is found on page 126 at the bottom. Can you see A is the negative of the integration? Can or cannot? Can, okay. Then, let's look at example 9. All of you look at example 9. Okay, let's look at example 9. It looks horrible, but actually it's quite okay, okay? Now let's take a look at example 9. The diagram shows part of the graph of this. The x-coordinate of point P is 3/4. The x-coordinate of point Q is -2. Find the total area of the shaded region divided by the curve, the x-axis, and the lines from P and Q perpendicular to the x-axis. Now I need to stress this. All of you look up. This is a very important thing, and students make this mistake in the exam. Ryan, second time. Now, I know this is -2, this is 3/4, right? Correct. They want this region, right? All of you look up here. Can you see that when I integrate from -2 to 0, I will get this region? When I integrate from 0 to -3/4, I must put a negative, right? Then I'll get this region. Then I plus together, correct? Now, I want to ask a question. Is it okay if I integrate from -2 to 3/4? Will you get the correct answer? No, you will not get the correct answer. Okay, now why? Let me show you here, okay? Can I show you over here? Okay, all of you look up. Okay, all of you look up, please. This is important, okay? Am I that right? Correct now. Okay, all of you look up here, please, please. If I integrate from here, -2 to 0, I will get this area, correct? Correct now. If I integrate from 0 to 3/4, I will get this area, right? But I must negative it, right? To make it positive. So I will get one value plus one value, I get the answer, correct? Now, what if someone integrate from -2 to 3/4? Actually, you are taking this area, you minus this area, no? All do together. So your answer will be less, no? You get what I mean? Because this is a negative value, you know. Okay, now I show you the numerical of it, okay? Let's say, okay? All of you look up, Let's say this one is 4 units squared. Let's say this one is maybe 2 units squared. All together must be what? 6, right? All together must be 6 units squared, correct? But if you do from here to here straight, right? You will get 4 minus 2, you will get 2 units, which is wrong. You get what I mean? Because this is a positive value, this is a negative value. You have to negative it to make it positive. That's why it's wrong. Everybody knows what I'm talking about here. Can or cannot. So you must do it separately. Those that is above and those that are below. Everybody knows what I'm talking about? Can or cannot. Can, Okay, good. Now, let's look at the question again. Find the total area bounded by the curve, the x-axis, and the lines from P and Q perpendicular to the x-axis. Okay. Now, first, I want to find the area A. All of you look at the board. Now, I know it's tedious. Come on, this is the 3rd year or almost 5,000 years I'm teaching this already. Okay? Can you please look up? Now, I want this area A. I must integrate from -2 to 0, right? So, I integrate this one. So, I do. Finally, I sub in everything. I will get 28/3 units squared. Everybody okay? Can you see I do the integration and then I sub in? Okay? Now, how do I get this tiny little bit? I must integrate from what? Whole class. I must integrate from what? 0 to what? 0 to 3/4, right? But because it's below, I integrate from 0 to 3/4, I must put a negative sign. So I integrate, I sub in, I will get this answer. Okay? So total area will be these 2 plus together. Plus this, so I will get, correct to the 3-centimeter figure is 10.0 units squared. Everybody clear? Everybody clear? 10.0 units squared. Are we okay? Alright. Now, I want to try something here with the plus. What if I integrate from negative 2 to 3/4? Do you think I will get the same answer? Do you think I will get the same answer? 10 answer? No, because I will have this minus this, right? Alright, let's try, okay? Let's try now. Okay, if we integrate, what do I get here? X4 over 4, right? Correct? Last one. Correct? Yes or no, class? I'm talking to you. Yes or no? Yes, huh? Okay. So this one will become right now. Yes or no? Okay. Now, I want you to sub in 3/4 into all this and tell me what's the first answer. Can all of you sub in 3/4? Use a calculator. Sub in 3/4 into all this and give me the answer. Sub in properly, huh? What's the first answer? Is it 171 over 256? Is this 171 over 256? Yes or no? Okay, then I minus. Can you sub in negative 2 into all this? Can I borrow it? Because you all look very tired. I'm scared to key in normally. You just substitute in. I made a mistake here. Yes. Yes, I did. Okay, those that you have done, what do you get the first answer? It's negative something, right?
Negative 1.16.
No, I want a fraction. 351. 351 over. Is it correct? I want all of you to key in. Okay, you all right back. Don't key for me. I'm back at you now. Key now. Negative 351 over 256, right?
Yes.
Then I minus. Okay, what is this when you key in negative 2?
4.
This is 4, right? Can you see the answer is different? Can you see the answer is different? Do you get what I'm talking about here? Yes or no? Okay, wait, I check the answer, see if I'm correct. Aiyo, 笑了。Yeah. Okay. So, do you agree that answer is different? Understand? So we cannot do it this way. Do you understand what I'm talking about? You got to add them up separately. Are you clear? If not, you will have been lumped together. Everybody clear? Everybody clear? Who is not clear with what I'm saying? Are you all okay? Are you all okay? Okay, good. So that is your part. Example 9. 10.0 units squared. Are you okay? Alright, good. Next, example 10. This is the one that I'm worried about. Area of a region between a curve and the y-axis. Okay, can all of you look at this particular explanation? All of you look up. The area A bounded by a curve x equals to gy. That means x written in terms of y. Okay? The y-axis and the lines y equals to c and y equals to d, where x bigger equals to 0 is on this side. Okay, it's given by when you integrate c to d, gy. Understand? And down here is what? Dy. Everybody clear? Can or cannot? Can, Okay, now, so how is this going to be applied? Can all of you look at this particular example? Example 10. I have two more examples. Okay, I only have two more examples. Can you all listen to me? Okay. Now, I have 1 to 9, y equals to 9x squared. Okay, the question says this. The diagram shows part of the curve y equals to 9x squared for x bigger equals to 0. Find the area of the shaded region bounded by the curve y equals to 9x squared. The y-axis and the lines y equals to 1 and y equals to 9. Now, all of you look up here. It's important. I must integrate with respect to y now, right? So this one cannot be. This is y in terms of x. Do you agree y is 9x squared? So x squared is y over 9, right? X will be plus or minus square root y over 9, right? Okay? Now, how come I didn't take the negative? The question say what? X bigger equal to 0. So I must take the positive. Correct now? So it's y half over 3 or 1/3 y half. Everybody clear? Okay. So you see when I integrate, right? I integrate from 1 to 9, 1/3 y half dy. Can you see it now? Dy. Okay. Then I do the necessary integration. I will get a 5/7 over 9 units squared. Are we all okay? Are we all okay? So what is the moral of the story? When we have this type with respect to y, you must put x in terms of y. Understand? You cannot anyhow integrate. Everybody clear? Is that clear? Okay? Alright, good. So that is your example 10. Okay, after I finish example 11, I will give you a break. Can you please listen to me, please? Okay, I know you are tired. Help me out. Alright? Let's look at example 10. Okay, let's look at example 10. Sorry, not example 10, example 11. Oh, sorry, there are two more examples. So I have to do the two more examples. Okay? Alright, let's take a look at this one. It's very fast one, don't worry. Okay? Now, let's take a look at the question. What did they say? Example 11. Hello? 4, 3, are you still alive? Sorry, even if you are dead, right, you must listen to me, I don't care. Okay, let's look at example 11. The diagram shows the region P bounded by the curve y equals to ln x. the x-axis and the line x equals to 3. Find the area of the region P. P here. Okay? Now class, let me just tell you this. This one when I sat in the exam, a lot of people will say, oh, it's like that. Y equals to ln x. So I just, this is 1, right? This is 3, right? So I just integrate from 1 to 3 ln x. We didn't learn integration of ln. There's no integration of ln. There's only integration of 1 over x. Do you understand? So we must go the other way, the y direction. Everybody clear with what I'm saying? Okay? I repeat again. A lot of people will go and self-invent. A lot of people will go and self-invent the integration. You understand? And it is totally wrong. Do you follow? Okay, that's why I say a lot of people will integrate 1 to 3 ln x. This is wrong because we never learn integration of ln x. We only learn differentiation of ln x. Everybody clear? Okay. Then how do I get P? All of you look up. In order to get P, right, I will take this square, right? I minus off this green color Q here. Okay, right, then I'll get the P, right? Can you see what I'm talking about here? Okay? Alright, now, let's take a look here. This graph is y equals to ln x. That means x is EY. Right? Do you agree x is EY? Correct? Okay. So, area of Q, that means from here to here. Now, when x is 3, this will be ln 3, agree? Yeah, I'm talking to you. Yes or no? When this is 3, this is the graph, 3, so it's ln 3, this is ln 3, right? So I integrate from 0 to ln 3, right? I integrate this one, correct? No? Because I'm with respect to the y-axis, so I integrate this one. So I have this. Okay? Then I will find, I will get a 2-unit square. Okay? Then how to get the red color P? Do you agree that this rectangle here is length times breadth, 3 times ln 3. Then I minus off this Q value, right? I will get the P. Agree, class? Okay, I'll get the P, yeah? So, area of P will be this, then I minus 2. Can you see? I'll get this answer. Everybody okay so far? Can see or not? Okay? So, sometimes you must see whether we are integrating with respect to x or with respect to y. You cannot see the thing, then straight away integrate. Okay? Alright, don't worry. The last one, I really give you a 5 minutes break. Alright? Now, let's take a look at this. Example 12. It's a very fast one. Okay? The line PQ intersects the curve x equals to y squared at the point R. Find the area of the region bounded by the y-axis, the line PQ, okay, and the curve x equals to y squared. Basically, it's the one shaded down here. You want to find this whole thing. Are we okay? Are we okay here? Can or cannot? Can or cannot? Okay. Now, first of all, I must find what do you call that? I must find the equation first now. Understand? Of PQ. Are you with me or not? Or you're dead already? You cannot be dead. This is the last one, really, confirm. Okay, can you please listen to me first, okay? Because I don't want to stop the video, then after I start again. It's very difficult to upload. You understand what I'm saying? Okay, now let's take a look at the question again. The line PQ intersects the curve x equals to y squared at the point R. Find the area of the region bounded by the y-axis, the line PQ, and the curve x equals to y squared. Now, first of all, I got to find the equation of PQ first. So all of you look here. I find the gradient of PQ. I can find, right? I use the gradient formula, right? Then y equals to minus half x plus c. I can see that the y-intercept is actually 4. Can you see it? It cuts the y-axis at 4. Okay? So I actually want to find the coordinates of R. Agree? I want to find the coordinates of R. So substituting in, okay, you see I have this equation, and then I have x equals to y squared. I sub in, I will get these two values. Okay, x equals to 16 and x equals to 4. Now, may I know why x equals to 16 is rejected? You look at the diagram. Why is x equals to 16 rejected? Can you see this is 8 and 16 is over the other side? So it must be the 4, right? Agree, class? Can or not? Okay, so r, the x coordinate is 4. So when I sub in, okay, 4 here, I will get y as 2, right? Correct or not? So the coordinate of r is 4, 2. Do you agree? I'm talking to you. 4, 2, okay? Alright, now, how do I get the area of the required one? Can you see that? Class, listen, this is important here. Hello, hello? Look at this curve. Until here is area under the curve 0 to 2, right? With the y-axis. Then after here is a triangle, right? Can you see it? Okay, so from 0 to 2, y squared. Can you see? Y squared by dy. Then, how to get this triangle? This is 2 units, right? This is how many units? 4 units. So, half times base times height. Can see what I'm talking about here. Therefore, you get the answer 6 2/3 unit squared. Everybody okay? Everybody okay? Now, I'm going to draw again. Then I will really give you a 5 minutes break. Can you please look out here? All of you look up. I want this area. Okay? I want this area that's shaded. Do you agree that I got to split it into 2? This is the area that's under this curve with respect to the y-axis. But this is a triangle, correct? It's no longer under the curve, it's a triangle. So it's half base times height. That's how I get this one and then I plus. Everybody okay? Everybody okay? So that's how I get your example 12. Okay? Okay. Teacher, stop the video, go to the toilet, 5 minutes break, go.